Okay, cool. So, okay, we're good. Nice. So getting started here, we're going to be exploring functions of continuity today and tomorrow. So the goals here, talking about today's goals real quick, we're going to determine whether functions are one-to-one and or onto. We're also going to determine if they're functions. We're going to determine the continuity, domain, and range of the functions. We're going to be able to write the domain and the range of functions using different notations, using set builder and interval notations. And then we've got a lot of vocab as well. So this will be vocabulary for today and tomorrow. We're going to have domain. We're going to introduce a new one called codomain. We'll be talking about range. We'll talk about one-to-one functions, onto functions, continuous functions, discontinuous functions, discrete functions, algebraic notation, set builder notation, and interval notation. It's a lot of definitions, a lot of vocab that we're going to be looking at. But each one of those has a particular function that we will actually use, and I'm pretty sure you'll get used to using these things pretty quickly. All right. So I'm just going to go back, and we're going to introduce things kind of from a basic level here. So a function, you've seen this before. A function describes a relationship between input, x, and output, y values. And even if you want to do this, if you want to put a little x above the input and a little y above the output as a reminder, is never a bad idea. The domain is the set of x values to be evaluated by a function. The codomain is the set of all the y values that could possibly result from the evaluation of the function. So basically, if a function has a domain of all real numbers, that means that the codomain is all real numbers. It does not mean that the domain itself is all real numbers. And we'll talk about this as we go down and look at example one. So, but the domain is the x values. The codomain is the set of all the y values that could possibly result from the evaluation of the function. The codomain of a function is assumed to be all real numbers unless otherwise stated. So we will assume, unless it says otherwise, that a codomain will be all real numbers. Because generally speaking, functions have domains that are all real numbers. Now, the range is the set of y values that actually result from evaluation of the function. The range is contained within the codomain. So the range is either equal to the codomain or it's a smaller set of values within the codomain. Because if the codomain is all real numbers, that's every single number. So an actual range would be within all of the numbers, or it is all of the numbers. It's one of those two things. All right, we saw this in the warm-up. If each element of a function's range is paired with exactly one element of the domain, so if every x has only one y value that goes with it, then the function is one-to-one. Now, in terms of onto, we never really crafted a definition of that. We saw the visual, right? If it crossed, if the horizontal line crossed the function at any point, that made it onto. If it missed the function, then it was not onto. But here's our definition. If a function's codomain is the same as the range, and if you go back and you think about those functions, we had the straight line that looked like that. It went positive and negative on the x's, and it went positive and negative on the y's forever in both directions. We also had the last function that came down and went up, and scooped back down, then went back up again. So it was all real numbers here, and it was all real numbers here. The one function that was not onto was the parabola. It only went up forever, it did not also go down forever, but the domain went left and right forever, all real numbers. So if the domain and the codomain and the range, basically if all those three things match up, it's specifically though it says codomain and the range are the same, then it is onto. So there's a study tip off to the side. We did this in the warm-up. Place a pencil flat at the top of a graph and move it down to represent a horizontal line. If there are places where the pencil intersects the graph at more than one point, then more than one element of the domain is paired with an element of the range, which means it is not one-to-one. We saw that in the warm-up. We also saw the onto as well. So it basically is recapping what we saw in those explore activities. So here we go. Let's take a look at example 1. Identify the domain, the range, and the codomain. So, because there are no restrictions on the x values, we assume that the domain is what? It says unless otherwise stated, assume that the domain is I'll go back up here real quick. The codomain of a function is assumed to be all real numbers unless otherwise stated. If there is a function, can this graph go left forever? Is it going to keep going left forever eventually? Yeah, it'll happen kind of slowly, but it'll happen. What about right forever? Yeah. So if every number is available, what do we say? Possibilities for x? All. What are the two words after that? Real numbers. There we go. All real numbers. We'll be writing that in a different notation as we move through this lesson. All right. Because the maximum, now we're talking about range. The one in the middle has to do with the range. Because the maximum value of y is 0, that means it can't go above 0. The range is y is less than or equal to 0. Yeah, it's either 0 or less than 0. So y is less than or equal to 0. Because it is not otherwise stated, or because it is not stated otherwise, the codomain is all real numbers. Yeah, unless otherwise stated, we assume the codomain is all real numbers. Nice. Here's your first bit of domain range and the new one, codomain. All right. Questions on that? For example 1. Let's keep going. This first lesson's pretty long. Again, that's why we're taking 2 days on it. All right, part B. Use these values to determine whether the function is onto. All right. So visually, hopefully we can kind of see that answer already. But it says the range is not the same as the codomain because it does not include the blank real numbers. Sorry, this is still referring to the original function on the previous page. This one goes with the upside down parabola on the previous. It does not go with that one. Those do not go together. So if you go back to the last one, it says the range is not the same as the codomain because the range does not include which real numbers? Positive, yeah. It doesn't include positive numbers. The actual domain included all real numbers. The codomain included all real numbers, but the actual range is not the same as the codomain because the range does not include the positive real numbers. Therefore, the function is or is not onto. If a function is onto, that means the codomain and the range are the same. If the codomain and the range are not the same, then what are we saying? Is or is not? Is not, yeah. Is not onto or isn't onto. There you go. So here's our next question. For what codomain is f of x an onto function? So if you were going to match, so in order for it to be onto, let's do a quick review on this. In order for it to be onto, the range and the codomain must be the same. So basically the best way to figure this out is figure out the range. Because if the range and the codomain must be equal for it to be onto, we can find out the range and then apply that same thing to the codomain and say, hey, those two things would have to be the same for it to be onto. So what's the range? What are the possible y values of this function? How high or low does the function go? Right? Goes as high as 3. So which of those would indicate y values that don't go higher than 3? A, yeah. Y is less than or equal to 3. It goes up to 3, and it's definitely everything 3 or below 3. So that's the range. So if you were going to have an onto function, the codomain would have to be the same thing as the range. Therefore, the answer is A. But in fact, the codomain is not the same as the range here. So this is not an onto function. But if it were, you'd have to have it as the same as the range, which is A. Questions on that? Heads are spinning a little bit. It's okay. It's our first real day of like new stuff, right? We saw a lot of review stuff on Thursday, Friday. Okay. Not seeing a lot of hands up. If you don't know what questions to ask yet, that's okay too. I do have TAT today if you want to drop by, but whatever problems I give you to work on today, they won't be due until Wednesday. So, all right. Let's look at example 2 then. Identifying one-to-one and onto functions. So the table shows the number of medals the United States won at 5 Summer Olympic Games from 2000 to 2016. So we got 2000 to 2016 U.S. medals, gold, silver, and bronze right there. So we are going to analyze the functions that give the number of gold and silver medals won in a particular year. So basically, everything together. We're going to define the domain and the range of each function, state whether it is one-to-one, onto, both, or neither. So let's talk about gold medals for a second. In 2000, there were 37 gold medals won. In 2004, there were 36 gold medals won. In 2008, there were 36 gold medals won. In 2012, there were 46. And in 2016, there were also 46. So let's take a look at gold medals down here on the left. Let f of x be the function that gives the number of gold medals won in a particular year. The domain is in the column year. So the years would be the domain values x. And the range would be the number of gold medals. In terms of one-to-one, what is our definition of one-to-one? Should be on the previous page. Feel free to look it up. For each element of the domain, there is what? Yeah, only one element in the range. Is that true for gold medals? For each element in the domain, is there only one corresponding value for the range? In 2004, that means that 36 would need to be a unique value. When you get to 2008, what do you see? 36. So each domain value does not have a unique y value because 36 doubles up, as does 46. So if you were to put these on a graph, by the way, if you were to put these on a graph, you would end up with 2 points horizontally that would be intersected by your horizontal line, which would fail the one-to-one test. So not one-to-one. Is not one-to-one. Or isn't one-to-one. If you have the same y value in a function, it's not one-to-one. All the x values are different. It is a function. We're not questioning whether or not it's a function. We're questioning whether or not that function is a one-to-one function. Okay. It is not one-to-one because two values in the domain, 2016 and blank, share the same value in the range 46. Which one is also 46? 2012, yeah. And then two values in the domain, 2008 and 2004, share the same value in the range, which is 36. There you go. Cool. All right, and then it says at the bottom here, just answers this for us. The function is not onto because the range does not include every whole number. Why would it need to include every whole number? The function is not onto because the range does not include every whole number. I think that means that the codomain is every whole number, right? Because if the range and the codomain are the same, and the codomain should match up with the domain in terms of possibilities. So what are the values in the domain? Go back here. What are our domain values here? Domain values are what? Years. Okay. So whole numbers are positive whole numbers and zero. So if we think about whole numbers, you know, in terms of like modern timekeeping, year zero would have been the first year, then year one, and then year two, and then three, and then four. So possible years would be zero through keep going, right? Whole number values. That would be the codomain because that's what the domain is. However, clearly we don't have all of those possible over here, right? The range does not match with the codomain in any way whatsoever. Therefore, it is not onto. Now we're gonna do the same thing for silver metals. Same idea. I want you to try to fill those silver metal ones out on your own. There's two things to fill in with silver metal. So take a minute on that. Just looking ahead a little bit, see what else we got. I think you'll end up with a decent amount of work done tomorrow, by the way, in class, which will be nice. And I think the wording for silver metals should make the answers relatively apparent. So for silver metals, it reads, let g of x be the function that gives the number of silver metals one in particular year. Same thing as gold metals. The domain is the column here. Same thing as gold metals. The range is the column number of silver metals. Basically the same thing as gold metals except for silver. The function is, yeah, it is one-to-one. Because no two values in the domain share a value in the range. Yeah. Every single domain value has a different range value. None of the range values are the same. Every single number of silver medals between those 5 Olympics was a different number. Therefore, it is 1-to-1. It is not onto because of the same reason for the gold medals. The function is not onto because the range does not include every whole number. All right. So that's a way that you can identify 1-to-1 and onto, given these would be considered discrete values because they're not like, you wouldn't draw a line to put those on a graph, right? You just put the points on there. You just put dots on the graph. You wouldn't connect them because they're just different points out on the graph. But looking at a different set of values, different sets of values here with domains and ranges, you can figure out whether or not they are 1-to-1 or onto, just like we did. Questions here before we look at example 3? All right. From a graphical perspective, these ones are going to look very similar to the explore activities that we did at the beginning of class. So hopefully these ones will be a little bit more straightforward. If not, that's okay. We'll keep practicing tomorrow. So determine whether each function is 1-to-1 onto both or neither for the given codomain. This one, it tells you what the codomain is right here. It said, unless otherwise stated, assume it's all real numbers. This one says codomain is all real numbers. This one does not say that. H of x does say that. So because the codomain on g of x is a little bit wonky, we'll do that one together. I want you to do f of x and h of x on your own, and then we'll come back and do g of x together. I'll give you 2 minutes to work on f of x at the top and h of x at the bottom there, and then we'll come back and do g of x in the middle in 2 minutes. If you have questions as you're working through these, let me know. I'll help you out. And even to some degree, the way that these are written kind of hopefully leads you to the right answers. All right, so for f of x, codomain, all real numbers. The graph indicates that the domain is all real numbers. It's indicating that the domain is all real numbers because it's going left and right forever if you extend that graph. And the range is all positive real numbers. You can see it levels out at 0, therefore the y values have to be greater than 0. Every x value is paired with exactly one unique y value, so the function is, this is 1-to-1. And if you want to, you can just take a pencil or a pen and lay it over using the horizontal line test. As long as you're not covering more than 1 point at the same time, it's 1-to-1. So it is 1-to-1 because the horizontal line will never intersect that graph in more than one place. The codomain is the set of all real numbers, which means that the range, which is y is greater than or equal to 0, that would be the range, is not equal to the codomain, which is all real numbers. So the function is not onto, isn't or is not onto. Any questions about our 1-to-1 versus onto on f of x? Okay, let's go down and look at h of x, and we'll go back to the middle and look at g of x after that. So h of x. Hopefully we all got this one because this looks just like the one we had in the warm-up. The graph indicates that the number in the domain and the range are both all real numbers. So it goes left and right forever, it goes up and down forever. So all real numbers all the way around. Every x value is paired with exactly one unique y value. So the function is or is not one-to-one? Is, good, all right. The codomain and the range are equal. So the function is onto. All right. So yes, yes, for one-to-one and onto for that one. Now, g of x, a little bit different. Now, had this one said that the codomain is all real numbers, we would have a different answer for onto. We would not have a different answer for one-to-one. Now, this says that the codomain, this says for all y values, this is how we read this, for all y values, y is less than or equal to 4. So basically, it's just saying that the codomain are y values that are either 4 or less than 4. What's the range of this function? That's right here. Y is less than or equal to 4. Do the codomain and the range match? Yes. Okay. That will be a big thing once we get to the onto portion of this. So the graph indicates that the domain is all real numbers because it goes left and right forever, and that the well, we're gonna have a quick fire drill. We go to Amaton. So just stay as a group, go out to Amazon, not Amazon, Amaton Field, head down those stairs there. I'll be right out with the class list. We'll take attendance and then we'll be back in a few minutes. Okay, let's keep going here. So we talked about the codomain matching the range. All right, so looking at the function itself, each x value is not paired with a unique y value. So if you place a horizontal line, there are plenty of places where a horizontal line will intersect two y values at the same time. For example, both x equals 0 and x equals 2, right here and right here, are paired. Oops, x equals 0, x equals 2 here and here are paired with y equals 3 right there and right there. So the function, in terms of one-to-one, yes or no? No, is not. It is not one-to-one. It is a function. It is not one-to-one. But because the codomain was adjusted and it now matches the range, onto, yeah, it is onto. Great. All right. That's it for notes for today. We'll finish the rest of these tomorrow. Don't put this away yet. I want you to skip ahead a couple of pages. Go to page 9. I'm gonna have you write down what the assignment is. You can get started on this if you want to. You can wait till you start it tomorrow if you want to as well. But you're gonna be working on numbers 1 through 39 odds. And